Hey everybody, it's Mr. Carr again. Today we're going to be looking at 2.5 day one. I know we took a bit of a break from this, but we're going to go back to our solving quadratic equations. Today we're going to be doing it using what? Square roots. So when can we use that? So if a quadratic equation has no x term, then we can solve it using square roots. So when I'm saying no x term, I mean like in terms of ax squared plus bx plus c. So this is not there. So that's what we're looking at in this scenario. So we're going to try to do this in a way where we have our exact answers. So again, no decimals. Okay. So in this case here, if I think about it as order of operations, x is being raised to the second power, then it's multiplied by 2. My third operation is subtracted by 5. So to solve that, I'm going to undo that. I want to undo the subtracting by adding to both sides. So 2x squared is equal to 200. I want to undo my division or my multiplication with division. So x squared equals 100. And now I can undo my squaring. To undo, like the opposite operation of squaring is square root here. But there's one thing that is important to remember. When we do x squared equals 100, there are actually two answers that work. If I take the square root of 100, that's 10. But if I take 10 squared, that's 10 times 10, giving me 100. But so is negative 10 squared, because negative 10 times a negative 10 is also 100. Meaning there's two answers that work here, a plus or minus 10. So this is what's called our square root property. Whenever we take the square root as part of our solving steps, we need to take the plus or minus square root. Okay. Okay. So I'll do the same thing for the next one. It is squaring, multiplying, adding. So I will subtract to start. So 3x squared is equal to a 36. Divide both sides by 3. So x squared is equal to 12. And then I square root here. So again, it's going to be a plus or minus square root. Additionally, we're doing the square root of 12. We can break that down like we've done before. So since 12 is 4 times 3, I take the square root of 4 and the square root of 3. So it becomes a 2 radical 3. So again, my final answer here is plus or minus 2 radical 3. Okay, solve a few more here. So if I subtract 11 to both sides, so 2x squared is equal to a negative 48. Divide by 2, so x squared is equal to a negative 24. And this is a good one because notice how we're taking the square root of a negative. Now we have what we need to do I as part of our solutions. So two things. Number one, let's break down the square root of 24. That is, 4 times 6. So I can do a perfect square with 4. And then I'm going to be left with a 6. Additionally, because the negative sign, that means it's going to be a plus or minus 2i root 6. So again, the 24 breaks down into the 2 root 6 here because of the square root of 4, square root of 6. But then the negative sign makes it an I as part of my answer as well. Over here, we'll do minus 33 to both sides. So 5x squared is equal to a negative 30. Dividing by 5 gives me x squared is equal to a negative 6. This does not break down any further than the 6 here. So x is equal to a plus or minus I root 6. We just don't want to keep the negative there. We just want to make sure it's written as a imaginary number. So we can also do this process when we're solving our vertex form. Okay. Problems like this can still be worked through. We're going to still undo my operations is the idea. Now, do not expand the problem using FOIL. Technically, you could do it, but honestly, you're making more work than necessary. So when I look at this one here, for example, again, my order of operations, it is added by 3, raised to the second power, multiplied, and then subtracted by 4. So if that's my normal order of operations, like 1, 2, 3, 4 in that order, I'm going to undo those going the opposite direction. So I'm going to first undo the subtraction to both sides. So 2 times z plus 3 squared is equal to 10. Now I could divide both sides by 2, so that z plus 3 squared is equal to 5. From here, I'm going to square root both sides. And again, we're going to use the square root property. So that's going to be z plus 3 is equal to a plus or minus root 5. And finally, I'm going to subtract 3 to both sides. 3 does not combine with the radical. So I'm just going to write my exact answer as -3 plus or minus the square root of 5. Okay, same thing here. Get rid of the -10 first. So we get x minus 1 squared is equal to 25. We square root both sides so that x minus 1 is equal to a plus or minus 5. So then I'm going to add 1 to both sides here. So x is equal to 1 plus or minus 5. I get two answers here. This one I leave alone because it's got the radical. I can't do anything else with that. But this one I could split up because it's going to turn into 1 plus 5 and 1 minus 5. So when I do x equals 1 plus 5, I get x equals 6. 1 minus 5, I get x equals a -4. Okay. A couple more to do some word problems here. When an object is dropped on Earth, its height in feet above the ground after t seconds is given by this equation. Oh, where h sub 0 is the initial height. So if I look at that, zoom out a little bit. Wile E. Coyote just dropped an anvil from a height of 50 feet. How long does it take it to, how long does Roadrunner have to open an umbrella to protect himself from the anvil? Some old references here. So because it's a word problem, we are going to round these answers off. I don't want exact answers. So the idea is that h of t is equal to a -16t squared plus my initial height. Okay, that's what this is saying here. So in this case, my initial height is 50. From here, I'm going to start with when it reaches the ground height is going to be 0. So this is what I'm solving for. So we'll subtract 50 to both sides. So -50 is equal to a -16t squared. Divide by a -16. So give me a second here out of the calculator. Sorry about that. Flip up the calculator on that one. So I've got 50 over 16. Going to give me 3.125 for t squared. And then I square root both sides. Even though I'm doing the square root property, like I'm kind of doing the square root property here, I do not care about the negative answer. We don't have negative time here. So the square root of my 3.125 is going to give me 1.77 seconds for my time. Okay. One last answer here. From 2005 to 2015, we have the average cost of a new car is given right here. During which year was the average cost of the new car $22,500? So the idea is that that's going to replace C. So 22,500 equals 90.5 t squared plus 15,000. Solving this with my square root property idea, we're going to subtract 15,000. Okay, so we got 22,500 minus my 15,000 is going to give me 7,500 is equal to 90.5 t squared. And now we divide both sides by 90.5. 90 point, whoops. Just put in my calculator, sorry about that. 90.5. That comes out to an 82.87. I'm going to do some more decimal places because I got to take the square root. But 87.29 on that one equals t squared. So then I take the square root of that to both sides like there. So then I do that. I take the square root of that one. That comes out to 9.10 for t. So during which year was the average cost that? It's basically 9 years after 2005. So this happens in the year 2014 when we reach that cost of a new car. Okay, and that's it for today. So the biggest thing about this is we can solve quadratics by taking square roots as long as it's set up in a very specific way. It has to either be, if I come back a little bit, something like this where it's no x term, or something like this where it's in vertex form. But again, it's not just a single x because the x is inside the squared idea. So it has to either be in vertex form or just an x squared with no x value there. And that's it for today. So take care, everyone.